What would TaxiVis, a landmark urban visualization system from 10 years ago, look like if it were to be created within the context of an immersive analytics interface? We reimagine TaxiVis, reflecting at the same time on how a traditional visualization tool could be implemented in an immersive 3D virtual environment without losing its core functionality, and how this could potentially bring in new functionality. We call this new possible functionality immersive extensions. Our main idea to leverage the additional dimension enabled by an immersive approach is to extend the visualization to encompass the temporal component through a space-time cube metaphor. We propose extending the visual query model so that a user can query both spatial and temporal components simultaneously by creating and adjusting visual representations in the space-time cube view. We support all kinds of queries proposed by the original TaxiVis model, with the extension of handling the temporal component as inseparable from the spatial one. Another potentially useful use of 3D in the urban context, which we also support, is correlating the data with the urban topography. Other possible uses of 3D include layering query results, comparing patterns over time, and rendering alternative 3D views. Since the immersed user has access to two interaction devices, it's possible to perform simultaneous origin-destination brushing. Two-handed brushing can also be used for quick pairwise comparisons between two simultaneous selections. An interesting extension enabled by immersive analytics is the ability of inspecting urban data at different perspectives and scales, including egocentrically in room scale when desired. It is also possible to inspect data at real city scale, for example through street images. In our paper, we also discuss immersive extensions related to immersive collaboration and immersive engagement. Besides extending TaxiVis's functionality, we consider essential to effectively adapt the original system's functionality to an immersive context. To this end, we leveraged in particular a combination of embedded views, coordinated views, and contextual menus. In our paper, we present and discuss a series of examples that showcase how our adapted and extended design works for exploring the New York City taxi dataset. To reflect on how an immersive reimagination could reproduce and extend TaxiVis's workflows, we revisit case studies from the original paper from 2013. Our idea is not to replace TaxiVis, but to reflect on the potential benefits opened up by immersive analytics.